This is Manoj Yadav and you are watching Mechanotherapy. So guys, in our previous lecture we discussed about how to determine the value of reactions in case of simply supported beam or with point loads. Now in this lecture we will discuss how to determine the value of reactions in case of a cantilever beam. So you can see I have drawn a figure on the board. We have this cantilever beam which is fixed at one end and which is free at the other end. There is no support at this end. A load of 20 kilonewton is acting at point A and the load of 10 kilonewton is acting at point B. The distance from A to B is 1 meter and from B to C is 1 meter. Now we have to determine the value of reactions in this case. So our first step is the same, that is we have to draw the free body diagram for this beam. We will have to remove all the supports, and in case of in place of those supports we will have to draw the reactions. So you know that in case of fixed support we have one vertical reaction, one horizontal reaction and one movement. Now since the point is C, so we will take this reaction as RCH, that is horizontal reaction at point C. RCV, that is vertical reaction at point C. Now similarly the movement, we will give it the name as MC. Now there is no support at any other point. So we will draw these forces 20 kilonewton and 10 kilonewton. Distance is 1 meter and 1 meter. Okay. So our first step is completed. We have drawn the free body diagram for this cantilever beam. Now we will use the conditions of equilibrium for solving these reactions. Our first equation is sigma Fx equal to 0, that is sum of all forces, horizontal forces must be 0. You can see in this diagram there is only one horizontal force which is in positive x direction. So we will write the equation as plus RCH equal to 0. This is our first equation. Now second equation, sum of all vertical forces must be 0. I told you that upward forces are taken as positive and downward forces are taken as negative. So you can see only one vertical force is there in positive y direction, RCV. So we will write it as positive. Plus RCV minus 10 minus 20 equal to 0. So RCV equal to 30 kilonewton. Equation number 2. Now third equation is movement equal to 0. So we will take movement about this C point. Sigma, we will write sigma MC equal to 0. So when we write sigma MC equal to 0, it means to say that movement, sum of movements about point C equal to 0. So movements of these RCH and RCV will be 0 because perpendicular distance from point C is 0. And this movement is clockwise minus MC. So we will write it as minus MC. This will try to rotate the body in clockwise direction and this will also try to rotate the body in clockwise direction. So movements will be negative. Minus 10 into 1. Similarly minus 20 into distance up to point C. Since we are taking movement about point C, so we will have to multiply the distance up to point C, that is 20 into 2 equal to 0. So it will be MC equal to minus 40 10 50, minus 50 kilonewton meter. Here minus sign indicates that the movement, the direction of movement which we have assumed is opposite. Actual direction is opposite to that direction. So in answer we can write as MC equal to 50 kilonewton meter anti-clockwise direction. This is the answer for this question. Okay, so we have find out all the values of reactions. Horizontal reaction at point C is 0, vertical reaction at point C is 30 kilonewton and the moment is 50 kilonewton meter anti-clockwise. So this is all about the value of reactions in case of cantilever beams with point loads. Thank you everyone.